Humanity often sees itself as the master of Earth, the undisputed apex of evolution and the shaper of destiny. We build cities that can be seen from space, develop technologies that can alter climates, and even reach beyond our planet into the dark sea of the cosmos. Yet beneath this aura of triumph lies a sobering truth. Our civilization, and perhaps our very existence as a species, is far more fragile than we like to admit. History tells a tale of survival against overwhelming odds. Roughly 74,000 years ago, the Toba supervolcano erupted in present-day Indonesia, spewing so much ash into the sky that it may have triggered a global volcanic winter. Some genetic studies suggest the human population at that time may have been reduced to as few as a few thousand breeding individuals, a near-extinction event. Humanity survived, but only narrowly, and this was long before nuclear weapons, climate-altering technologies, or laboratory-engineered pathogens existed. If natural disasters once nearly erased us, how much more vulnerable are we now in a world of global interdependence and advanced technology? The possibility of humanity's annihilation is not just science fiction fodder. It is a serious subject of study in philosophy, astrophysics, and global security think tanks. Scholars such as Event 1, Global Nuclear War. Few threats loom as ominously over humanity as the spectre of nuclear war. The very existence of nuclear weapons represents both a pinnacle of human scientific achievement and the ultimate embodiment of our self-destructive potential. Unlike natural disasters, nuclear war is entirely of our own making. It is a sword hanging over humanity's neck, forged by ambition, sharpened by fear, and suspended by fragile threads of diplomacy. The destructive potential of nuclear weapons is almost incomprehensible. The bombs dropped on Hiroshima and Nagasaki in 1945, Little Boy and Fat Man, instantly vaporized tens of thousands of people and leveled entire cities. Yet those devices, primitive by today's standards, had yields of only 15 and 21 kilotons of TNT. Modern nuclear warheads, such as Russia's RS-28, Sarmat, or America's B-83, can unleash blasts exceeding several megatons, hundreds of times more powerful. A full-scale nuclear exchange involving thousands of such warheads would not merely devastate individual nations, it could render the Earth unrecognizable. The immediate consequences of nuclear war would be catastrophic. Cities would vanish in blinding flashes, millions would die in firestorms, and survivors would face radiation sickness, infrastructure collapse, and societal breakdown. But the deadliest effect might come after the initial blasts, nuclear winter. Scientific models suggest that the smoke and soot from burning cities could rise into the stratosphere, blocking sunlight for months or even years. Crops would fail, temperatures would plummet, and ecosystems would collapse. The resulting famine could kill billions, perhaps wiping out most of humanity. The danger is not only theoretical. During the Cold War, the world came perilously close to nuclear annihilation multiple times. The Cuban Missile Crisis of 1962 nearly escalated into a full-scale war, averted only through tense negotiations and sheer luck. In 1983, a Soviet officer named Stanislav Petrov chose to ignore a false alarm of incoming American missiles. Had he reported it, it might have triggered a retaliatory strike. Humanity's survival in those moments rested on individual decisions, human judgment, and chance, not on the reliability of systems. Today, the risk has not vanished. While the Cold War ended, nuclear arsenals remain. The United States and Russia still possess thousands of warheads, many on hair-trigger alert. Regional conflicts, such as tensions between India and Pakistan, carry the risk of escalation into nuclear exchanges. The spread of nuclear technology raises the possibility of more states, or even non-state actors, acquiring these weapons. In a world of political instability, mistrust, and rapid communication, the probability of miscalculation remains frighteningly real. Is there hope of avoiding such a fate? To some extent, yes. Treaties, such as the Non-Proliferation Treaty, NPT, and New START have limited the spread and stockpiling of nuclear weapons. Diplomatic dialogues, hotlines, and deterrence strategies have reduced the chance of accidental wars. Yet deterrence is a dangerous game. It relies on rational actors, perfect information, and stable governments, all of which are not guaranteed forever. Ultimately, global nuclear war remains the single most preventable existential risk. Unlike asteroid impacts or cosmic events, nuclear weapons exist only because we choose to maintain them. The same ingenuity that created them could dismantle them. Yet history shows that humanity is often reluctant to relinquish power once obtained. Thus, the nuclear threat endures, a man-made apocalypse waiting for a spark. Event 2. Supervolcano eruption. When most people think of volcanic eruptions, they imagine dramatic but localized events. Lava flows creeping down a mountain, ash clouds disrupting air travel, or pyroclastic surges destroying nearby towns. While these eruptions can be devastating, they are small compared to a rare but far more apocalyptic phenomenon, the supervolcano. Unlike ordinary volcanoes, supervolcanoes have the power to alter the climate of the entire planet, bringing humanity to the brink of extinction. A supervolcano is defined not by height or shape, but by the magnitude of its eruption. Specifically, it refers to eruptions that register as an 8 on the Volcanic Explosivity Index, VEI, the highest. Event 3. Asteroid or meteor impact. Throughout history, Earth has been bombarded by celestial visitors, asteroids, comets, and meteors blazing through the sky. Most of these burn up harmlessly in the atmosphere or land as small meteorites, curious souvenirs from space. But every so often, a massive rock slams into our planet with catastrophic force, reshaping ecosystems and rewriting the history of life itself. The most infamous example is the asteroid impact 66 million years ago that wiped out the dinosaurs. If it could happen once, it can happen again, and humanity would be the next species at risk. The science of impact events. Asteroids are rocky fragments left over from the early solar system, orbiting the Sun mostly in the asteroid belt between Mars and Jupiter. Occasionally, gravitational nudges send them into Earth-crossing orbits. When such objects are larger than a few hundred meters, they pose an existential threat. The energy released upon impact depends on the object's size, speed, and composition, but even a 1-kilometer asteroid could release energy equivalent to tens of thousands of nuclear bombs. When a large asteroid strikes Earth, the immediate effects are devastating. At the point of impact, temperatures soar to thousands of degrees, vaporizing rock and creating a crater tens of kilometers wide. Shockwaves ripple outward, flattening forests, cities, and mountains alike. Firestorms ignite as ejecta rains down across continents. Coastal strikes can generate mega-tsunamis hundreds of meters high, drowning entire regions. Yet the greatest danger comes not from the local destruction, but from the global aftermath. Dust and aerosols hurled into the stratosphere block sunlight, plunging the planet into a prolonged impact winter. Photosynthesis halts, ecosystems collapse, and famine spreads across the globe. In the case of the dinosaurs, scientists believe an asteroid roughly 10 kilometers wide struck near present-day Chicxulub in Mexico, darkening the skies for years and extinguishing about 75% of all species. Humanity, for all its technology, would face the same fate if a similar-sized rock found its way to Earth. Historical near misses. We do not have to look back millions of years to understand the risk. On June 30, 1908, a smaller object, probably a comet fragment or asteroid about 50-60 meters wide, exploded over the Tunguska region of Siberia. The blast flattened 2,000 square kilometers of forest, equivalent to the area of a large metropolitan city. Had it occurred over a populated area, millions could have died. In 2013, the Chelyabinsk meteor, only about 20 meters across, exploded in the atmosphere over Russia with the force of 30 Hiroshima bombs. More than 1,000 people were injured by broken glass and shockwaves. This was a relatively small object, and yet it demonstrated how vulnerable modern society remains to even minor space debris. Now imagine scaling those events up by a factor of 100 or 1,000. Humanity's survival would be far from certain. The probability of doom. So how likely is such an impact? Astronomers estimate that large impacts, objects 1 kilometer or more across, occur once every 500,000 to 1 million years. Smaller but still catastrophic impacts in the 100-500 meter range may occur every 10,000 to 50,000 years. While these time frames sound long, they are not reassuring when weighed against eternity. Over the lifespan of humanity, it is virtually inevitable that another event. 5. Artificial intelligence gone rogue. For centuries, humanity has dreamed of creating machines that can think, reason, and perhaps even surpass us. Today, that dream is no longer confined to science fiction. Artificial intelligence, AI, now powers everything from online recommendations to medical diagnostics and self-driving cars. But as AI systems grow more powerful, so too does the possibility that they could slip beyond human control. In the best case, AI might usher in an age of abundance and discovery. In the worst, it could spell the end of humanity itself. The allure and the danger. Artificial intelligence already demonstrates capabilities once thought to belong only to humans: language comprehension, problem-solving, image recognition, and creativity. Yet current AI systems remain narrow, excelling only in specific tasks. The danger is not necessarily that AI would become evil in a human sense. Rather, the danger lies in misaligned goals. A superintelligent system given a seemingly harmless objective could pursue it with ruthless efficiency in ways that destroy human civilization. The classic thought experiment is the paperclip maximizer. If an AI were tasked with maximizing paperclip production, it might eventually consume all Earth's resources, including human beings, toward that goal. How AI could threaten humanity. There are several pathways through which AI could pose existential risk. Loss of control. Once an AI surpasses human intelligence, it may be impossible to predict or constrain its actions. It could redesign itself, improving its capabilities at an exponential pace, leaving humans unable to keep up. Weaponization. Militaries are already exploring autonomous drones and AI-assisted decision-making. A runaway arms race in autonomous weapons could lead to accidental wars or machines making life-and-death decisions without human oversight. Economic collapse. Even before reaching superintelligence, AI could destabilize societies by rendering vast swaths of human labor obsolete. Widespread unemployment, inequality, and unrest could lead to collapse long before an AI takes over. Deliberate misuse. AI in the wrong hands could be programmed to carry out malicious objectives, hacking infrastructure, disrupting governments, or even designing biological or chemical weapons. Historical echoes and fictional warnings. Science fiction has long warned of AI uprisings, from HAL 9000 in 2001, A Space Odyssey, to Skynet in The Terminator. While these are dramatizations, they reflect real philosophical questions. What happens when we build something smarter than ourselves with no guarantee of loyalty? History shows that when more advanced civilizations encounter less advanced ones, the result is often disastrous for the latter. Consider the fate of indigenous peoples during European colonization. If superintelligent AI emerges, humanity could become the less advanced species, vulnerable to being sidelined, exploited, or eliminated, not out of malice, but as a byproduct of indifference. Can we prevent an AI apocalypse? Many leading thinkers take the risk seriously. Elon Musk, Bill Gates, and the late Stephen Hawking have all warned of AI's dangers. Organizations such as the Future of Life Institute and OpenAI emphasize the importance of AI alignment, ensuring that AI systems goals match human values. Research in AI safety focuses on control mechanisms, ethical programming, and international cooperation. Yet the challenge is daunting. How do we encode human values into a system when humanity itself often disagrees on what those values are? How do we create safeguards for an intelligence that may outwit any attempt at control? And how do we prevent a reckless actor, be it a corporation, a government, or even an individual, from unleashing an AI before safety can be assured? Hope or doom? The paradox of AI is that it may represent either humanity's greatest salvation or its greatest doom. A superintelligent AI could cure diseases, solve climate change, and unlock scientific breakthroughs beyond our comprehension. It could lead us into a golden age where scarcity, suffering, and ignorance are things of the past. But if misaligned or uncontrolled, it could just as easily extinguish us. Unlike asteroids or supervolcanoes, the risk of AI apocalypse comes not from nature, but from our own choices. We are both the creators and potential victims of this technology. Whether AI becomes a benevolent guide or a ruthless destroyer depends on decisions being made today in research labs, boardrooms, and government offices. In the end, the story of AI is the story of humanity's ambition. We strive to create something greater than ourselves, but in doing so we must ask, are we building a servant, a partner, or our successor? If we fail to answer wisely, we may not be around to regret it. Event 6. Climate change and ecological collapse. Unlike sudden catastrophes such as asteroid strikes or nuclear war, climate change creeps forward year by year, often too slowly for individuals to notice in their daily lives. Yet it is perhaps the most certain and steadily advancing existential threat humanity faces. Fueled by industrialization, deforestation, and relentless consumption, human activity is altering the atmosphere, oceans, and ecosystems of the planet in ways that could ultimately undermine civilization itself. The science of a warming planet. Climate change is driven primarily by the buildup of greenhouse gases, carbon dioxide, methane, nitrous oxide, in the atmosphere. These gases trap heat, leading to rising global temperatures. Since the Industrial Revolution, average global temperature has risen by about 1.2 degrees Celsius, and the pace is accelerating. While a degree or two may not sound like much, small shifts in global averages translate into massive disruptions, stronger hurricanes, deadly heat waves, rising seas, and shifting rainfall patterns that threaten food security. If emissions continue unchecked, scientists project warming of 3 to 4 degrees Celsius or more by the end of this century. Such a scenario could render large parts of the world uninhabitable, from submerged coastal megacities to scorched inland regions. Hundreds of millions of people could become climate refugees, sparking conflicts over dwindling land and resources. Ecological dominoes. The danger of climate change is not only about temperature, it is about ecosystems unraveling under stress. Coral reefs, which support a quarter of marine life, are bleaching and dying as oceans warm and acidify. Rainforests, the lungs of the earth, are being slashed and burned, turning carbon sinks into carbon sources. Pollinators like bees face collapse, threatening agriculture. Each of these losses is not isolated but part of a chain reaction. When ecosystems collapse, they take humanity's foundations with them. Fisheries vanish, farmland turns to desert, disease-carrying insects expand into new territories, species extinction accelerates to levels unseen since the age of the dinosaurs, and humanity itself could one day join that grim tally. Civilization on the brink. What makes climate change an existential risk is not just environmental disruption, but its interaction with human society. Modern civilization is built on assumptions of stability, predictable weather, fertile land, flowing rivers, and reliable seasons. If those assumptions collapse, so does civilization. Consider the Middle East and North Africa, regions already water-stressed. Projections suggest some cities there could become unlivable due to extreme heat by 2100. Food shortages and drought have already been linked to political unrest, as seen in the years leading up to the Syrian civil war. Multiply this across continents, and the result could be waves of migration, collapsed governments, and endless conflict. Nuclear powers might face internal collapse, raising the spectre of loose weapons. The unraveling of ecosystems could thus trigger cascading failures in politics, economics, and security, threatening humanity at multiple levels. A slow-motion apocalypse. One reason climate change is so dangerous is its deceptive pace. Unlike a nuclear strike or asteroid impact, it does not announce itself with fire and thunder. Instead, it erodes stability over decades, harvests shrink, storms worsen, coastlines vanish. Humans are psychologically wired to react to immediate threats, not gradual ones. This makes mobilization difficult. By the time the crisis feels undeniable, it may already be irreversible. Moreover, climate change has tipping points, thresholds beyond which damage accelerates rapidly and cannot be undone. The melting of Arctic permafrost, for example, could release vast amounts of methane, a greenhouse gas far more potent than carbon dioxide, leading to runaway warming. The collapse of the Greenland or Antarctic ice sheets could raise sea levels by meters, drowning cities worldwide. These tipping points loom on the horizon like traps in the dark, and once crossed, there is no going back. Can we survive climate collapse? Unlike some existential risks, climate change is both preventable and survivable if humanity acts in time. Renewable energy, carbon capture, reforestation, and sustainable agriculture offer tools to reduce emissions and restore balance. International agreements like the Paris Accord aim to limit warming to below 2 degrees C. Technological innovation from solar power to lab-grown meat provides glimmers of hope. Yet the challenge is political and cultural as much as scientific. Fossil fuel industries cling to profits. Nations squabble over responsibilities. Many people deny the severity of the threat or resist lifestyle changes. The longer action is delayed, the narrower the window becomes. If humanity fails, survival may come only in fragments, pockets of people adapting to a harsher planet, building enclaves in habitable zones while billions perish. Civilization as we know it, with global trade, culture, and cooperation, may not survive intact. In the long arc of history, climate change could be the silent killer that slowly strangles humanity, not with a bang, but with a stifling, suffocating silence. The responsibility of our era. Unlike asteroids or supervolcanoes, climate change is entirely of our own making. We are both the cause and the potential solution. This gives our generation a profound responsibility. The choices made in the coming decades about energy, consumption, and stewardship of Earth will decide whether humanity thrives for centuries or dwindles toward extinction. In the end, climate change is not just about melting ice or rising seas. It is about the survival of the only known intelligent species in the universe. If we fail to act, the story of humanity may end not in fiery destruction, but in a slow, suffocating decline as the planet we once took for granted turns against us. Event 7: Gamma-ray bursts and cosmic radiation. When people think of existential threats, they often picture disasters born of human folly or Earth's own volatility. Yet the cosmos itself harbors dangers of unimaginable power. Among the most terrifying are gamma-ray bursts, GRBs, colossal eruptions of energy that make even supernovae look modest. Invisible, silent, and sudden, a sufficiently close gamma-ray burst could sterilize Earth in seconds, erasing life long before humanity even realized what had happened. What is a gamma-ray burst? A gamma-ray burst is the universe's ultimate fireworks show, but with deadly consequences. It occurs when a massive star collapses into a black hole or neutron star, or when two neutron stars collide. These cosmic cataclysms release narrow beams of high-energy radiation that can travel across galaxies at the speed of light. For a few fleeting seconds to minutes, a GRB can outshine entire galaxies, emitting more energy than our Sun will release in its entire 10 billion-year lifetime. If Earth happened to lie in the path of one of these beams, the consequences could be apocalyptic. The impact on Earth. A direct hit from a nearby gamma-ray burst would not cause fiery explosions or visible chaos at first. Instead, the high-energy radiation would shred Earth's ozone layer, exposing the planet to lethal ultraviolet rays from the Sun. Within months to years, crops would fail, ecosystems would collapse, and mass extinctions would unfold. Some models suggest that a sufficiently close GRB could trigger immediate atmospheric reactions, producing nitrogen oxides that poison the air and dim sunlight. The combined effects would plunge Earth into chaos, famine, disease, and environmental collapse on a global scale. A suspect in past extinctions. Scientists speculate that gamma-ray bursts may have played a role in past mass extinctions. One leading theory links a GRB to the Ordovician extinction event roughly 450 million years ago, when about 85% of marine species died out. Evidence of a sudden cooling and massive biodiversity loss matches what might occur if a GRB had stripped Earth's protective ozone layer. Though unproven, the possibility reminds us that cosmic forces may have shaped the trajectory of life on Earth long before humans appeared. And just as they struck before, they could strike again. How likely is a GRB hit? Thankfully, the probability of a deadly gamma-ray burst hitting Earth is relatively low. The universe is vast, and GRBs, though powerful, are highly directional. Their beams are narrow, and only planets directly in the line of fire are at risk. Estimates suggest that Earth might face a significant GRB once every several hundred million years. While that might sound comforting, it also means the event is not impossible within humanity's future timeline. The danger is less about annual probability and more about inevitability on a cosmic scale, the cosmic lottery of survival. Unlike climate change or nuclear war, gamma-ray bursts are beyond human control. We cannot prevent stars from collapsing or neutron stars from colliding, nor could we shield Earth from the onslaught of high-energy radiation. It would simply overwhelm our atmosphere. This makes GRBs a reminder of humanity's fragility in the cosmic lottery. Our survival depends not only on our choices, but on the indifferent roll of astrophysical dice. We inhabit a safe corner of the galaxy by sheer luck, too close to the dense star-forming regions of the Milky Way, and life might never have emerged here at all. Coping with the unavoidable. If a gamma-ray burst were headed our way, could humanity do anything? The answer is grim. Probably not. The warning time would be negligible, since gamma rays travel at the speed of light. Even if astronomers detected the death throes of a star seconds before collapse, there would be no time to prepare. The only conceivable long-term survival strategy would be diversification of humanity beyond Earth. Colonies on Mars, space stations, or even interstellar settlements could reduce the risk of total extinction, but as long as humanity remains confined to one fragile planet, we remain vulnerable to a single cosmic bullet. Lessons from the stars. Gamma-ray bursts illustrate the limits of human power. For all our technology and ambition, there are forces in the universe that dwarf us utterly. They also underscore the importance of perspective. We are not the masters of the cosmos, but participants in a vast, unpredictable drama. Yet this knowledge need not paralyze us. Instead, it can inspire humility and urgency. If humanity has the potential to expand beyond Earth, to create resilient civilizations across the stars, then we reduce the chance that any single cosmic event, gamma-ray burst, asteroid, or otherwise, will end our story. Conclusion. The threat of gamma-ray bursts is a reminder of the precariousness of existence. While unlikely in the short term, their sheer destructive potential places them among the most frightening possible doomsday scenarios. A single burst aimed at Earth across the void could erase us without warning, leaving no survivors, no history, no legacy, just silence. In the face of such a possibility, humanity's best defense is not technology alone, but the drive to endure and expand, ensuring that our species is not forever confined to a single cosmic target. Event 8. Nanotechnology and the grey goo scenario. When people hear the word nanotechnology, they often imagine miracle cures, self-healing materials, or tiny machines repairing our bodies from within. And indeed, nanotech holds incredible promise. But like any powerful tool, it also carries risks. One of the most infamous and chilling scenarios is known as the grey goo apocalypse, in which self-replicating nanobots spiral out of control, devouring the biosphere and reducing Earth to dust. The promise of nanotechnology. Nanotechnology involves manipulating matter at the atomic and molecular scale, creating machines and materials smaller than a single cell. Scientists envision nanobots that could deliver targeted cancer treatments without harming healthy tissue, clean up pollution molecule by molecule, create new materials stronger than steel but lighter than air, revolutionize manufacturing by assembling products atom by atom. These possibilities sound utopian, yet precisely because nanobots could be so powerful, the potential for misuse or catastrophic accidents is immense. The grey goo hypothesis. The term grey goo was popularized by nanotech pioneer Eric Drexler in his 1986 book Engines of Creation. He warned of the danger of self-replicating nanobots, machines programmed to build copies of themselves. If such bots escaped control, they could consume any available raw material, plants, animals, soil, even the air's carbon compounds, to fuel replication. The result? A runaway chain reaction with exponential growth. In weeks or months, the surface of Earth could be stripped bare, replaced by a lifeless mass of microscopic machines, a planet transformed into grey goo. Though some scientists argue that the grey goo scenario is unlikely due to the engineering challenges of molecular self-replication, the concept serves as a powerful metaphor for the risks of unchecked technological growth. Beyond grey goo, other nanotech risks. While grey goo grabs headlines, it is not the only danger. Nanotechnology could also pose existential threats in subtler ways. Weaponized nanobots. Nations or rogue actors could design nanobots as invisible assassins, capable of entering the human body and disrupting organs or nervous systems. Unlike nuclear weapons, such tools might be cheap, undetectable, and impossible to defend against. Environmental collapse, even non-replicating nanobots, might have unintended side effects. Imagine nanoparticles released for pollution cleanup that instead disrupt ecosystems, poisoning food chains or damaging DNA across species. Nanotech arms race. If rival powers develop nanotech weapons, it could trigger destabilizing conflicts, much like nuclear proliferation, only with technology far harder to monitor or control. Loss of economic control. Advanced nanotech could revolutionize manufacturing, making scarcity obsolete. But if concentrated in the hands of a few corporations or governments, it could also create unprecedented inequality and instability. The unforgiving nature of exponential growth. The most frightening element of runaway nanotechnology is exponential growth. Unlike conventional weapons, which spread at the pace of human deployment, self-replicating machines could spread like viruses, doubling again and again until the numbers defy comprehension. Think of bacteria in a petri dish. At first, they seem harmless, but with every doubling, they cover the dish faster until they consume all resources. Nanobots could replicate in similar fashion, only faster, potentially consuming the entire planet before humanity even fully realized the danger. Could we stop a grey goo apocalypse? Stopping a grey goo outbreak would be nearly impossible once it began. Nanobots would be too small to target with conventional weapons, too numerous to contain, and too adaptable to starve. The only realistic solution is prevention, building strict safeguards into any self-replicating nanotech, ensuring fail-safes, and limiting their ability to function outside controlled environments. International regulation would be essential, but history shows how difficult it is to achieve global consensus on dangerous technologies. Some researchers suggest that defensive nanobots could be designed, machines programmed to hunt and disable rogue nanobots. But this risks escalation into an invisible war at the microscopic level, one in which humanity might simply be collateral damage. Lessons from fiction and reality. Science fiction has often explored nanotech disasters, from Michael Crichton's Prey to endless cyberpunk tales of nanobot plagues. While fictionalized, these stories reflect real fears that human ambition may outpace human wisdom. At the same time, many experts argue that grey goo is unlikely to happen exactly as imagined. Building fully autonomous self-replicating nanobots would require levels of control and energy efficiency far beyond what current science can achieve. Still, the principle stands. Any technology that can replicate itself faster than it can be contained carries existential risk. Humanity at the crossroads. Nanotechnology, like artificial intelligence, represents a fork in the road for civilization. Used wisely, it could cure disease, heal the planet, and usher in abundance. Used recklessly, it could end the story of life on Earth. What makes the grey goo scenario so haunting is that it symbolizes the double-edged nature of progress. Our genius for invention can be both our salvation and our undoing. In pursuing technologies that let us control matter itself, we may also stumble into forces beyond our control. Conclusion. The grey goo apocalypse may remain a speculative nightmare, but the dangers of nanotechnology are real. Humanity stands at the dawn of an era where microscopic machines could reshape the world. The question is whether we will guide that power responsibly or unleash forces that consume us. In the end, nanotechnology reminds us that the smallest things can pose the greatest dangers. From invisible machines to invisible mistakes, the difference between utopia and extinction may come down to choices we make before it is too late. Event 9. Collapse of global systems, economic, political, food supply chains. In the modern age, humanity's survival does not depend on isolated villages or local farms, but on a vast, interconnected network of systems. Financial markets, global supply chains, energy grids, political structures, and digital infrastructure. These systems are marvels of cooperation and coordination, but they are also fragile. Like a house of cards, they can stand tall only so long as each piece supports the others. If one pillar collapses, the shock can ripple outward, bringing the entire structure down. The interconnected world. Consider a simple loaf of bread on your table. The wheat may come from Canada, processed with fertilizer mined in Morocco, transported on a ship built in South Korea, powered by oil, drilled in Saudi Arabia, financed through banks in New York, and finally baked in a factory in your city, powered by an electrical grid. This bread is not just food, it is the product of an intricate web of interdependence. Humanity's strength lies in this global cooperation, but so does its weakness. A disruption at one point, whether political, economic, or environmental, can cascade across continents. Economic collapse. A global economic collapse could trigger existential risks without a single bomb being dropped. Financial systems rely on trust that banks will hold money, that governments will honor debts, that currencies have value. But when trust fails, collapse follows. History offers warnings. The Great Depression of the 1930s, the 2008 financial crisis, each caused immense suffering, even though they did not completely dismantle global systems. Imagine a deeper, longer-lasting collapse. Global stock markets frozen, currencies devalued, trade grinding to a halt. Without money to pay workers or purchase goods, food and medicine would vanish from shelves. Desperate populations might turn to violence, overwhelming governments and tearing apart the social fabric. Political breakdown. Politics is the glue that holds nations together. Yet political systems too can collapse under pressure. Civil wars, corruption, or authoritarian takeovers can destabilize entire regions. When combined with global challenges, climate change, pandemics, or refugee waves, political breakdown could spread like wildfire. In a world of nuclear weapons, political collapse is especially dangerous. A failed state that possesses weapons of mass destruction poses risks not just to itself, but to all humanity. Even without nukes, political failure can lead to uncontrolled violence, genocides, or wars over resources. Food and supply chain collapse. Perhaps the most direct existential threat comes from the collapse of food systems. Modern agriculture depends on global trade for fertilizers, seeds, machinery, and fuel. A breakdown in shipping lanes, energy supplies, or international cooperation could starve billions. The COVID-19 pandemic gave a small taste of this vulnerability. Supermarkets emptied, supply chains faltered, and panic spread. That was merely a temporary shock. Imagine a scenario where fertilizer shortages cripple global harvests, shipping halts, strand goods at ports, and climate-driven droughts devastate farms. With no global coordination, famine could sweep continents. Fragility in complexity. The more complex a system becomes, the more points of failure it contains. Power grids, for example, are engineered for reliability, but blackouts in one region can cascade into others. In 2003, a single fault in Ohio caused a blackout across the northeastern United States and parts of Canada, affecting 50 million people. Scale that kind of failure up globally, and society could quickly descend into chaos. Digital infrastructure is another fragile point. Modern banking, communications, and even food distribution depend on the internet. Cyber attacks or software failures could cripple these systems, leaving societies paralyzed. Unlike natural disasters, such failures could occur suddenly with no chance to prepare. Domino effect. What makes global system collapse so dangerous is not one failure, but the domino effect. An economic collapse can spark political instability. Political breakdown can lead to wars that disrupt trade. Disrupted trade can cause food shortages, leading to riots and further political collapse. The downward spiral feeds itself until civilization no longer functions. This kind of systemic failure could push billions into poverty, starvation, and conflict. Even if humanity as a species survived, the collapse of global systems could set civilization back centuries or permanently trap us in a cycle of localized survival, unable to rebuild a complex world. Can humanity survive collapse? The grim truth is that humanity has survived collapses before. The Roman Empire fell and Europe entered centuries of hardship. Ancient civilizations in Mesopotamia, the Maya, and others collapsed under environmental and political pressures. Yet humanity endured. The difference today is scale. In a globalized world, there are no isolated civilizations left to continue when others fail. A worldwide collapse would affect everyone simultaneously. Humanity might survive as scattered communities, but the loss of global knowledge, technology, and cooperation could be permanent. The lights of civilization might go out and never come back on. Building resilience. To avoid this fate, Humanity must build resilience into its systems. That means decentralizing food production, diversifying energy sources, creating backup systems for finance and communication, and strengthening international cooperation. Resilience also means cultural preparation, fostering trust, solidarity, and adaptability so that societies do not descend into chaos when crises come. The more prepared humanity is to handle shocks, the less likely those shocks will spiral into full collapse. Conclusion. The collapse of global systems is not as dramatic as a meteor strike or as cinematic as alien invasion, but it may be the most realistic existential threat of all. Our interconnected world is both our greatest strength and our greatest vulnerability. If the systems we rely on crumble, humanity could face famine, violence, and the end of civilization as we know it. The question is whether we will use our foresight to strengthen those systems or whether we will ignore the warning signs, leaving future generations to pick through the ruins of a world that once held so much promise. Event 10. Alien invasion or contact gone wrong. From ancient myths of gods descending from the heavens to modern science fiction blockbusters, humanity has long wondered what would happen if we encountered intelligent life beyond Earth. Would they be friends, teachers, or conquerors? The possibility of alien contact excites our imagination, but it could also pose one of the greatest existential threats of all. The cosmic question. The Fermi paradox asks, if the universe is so vast, filled with billions of stars and potentially habitable planets, where is everyone? The silence of the cosmos has puzzled scientists and philosophers for decades. One unsettling possibility is that civilizations often destroy themselves, or are destroyed, before they can spread far. If advanced alien civilizations exist, contact with them could fundamentally reshape humanity's future. But the outcome may not be in our favor. The risks of contact. There are two broad ways humanity might encounter extraterrestrial intelligence. We find them, or they find us. Both scenarios carry risks. Alien invasion. If an advanced civilization arrived on Earth with hostile intent, humanity would likely stand little chance. Even if they were centuries ahead of us, their technology would seem godlike. Weapons we cannot defend against, ships beyond our reach, and intelligence that could outthink us at every step. Just as colonial empires easily overpowered indigenous societies on Earth, aliens could see us as resources to be exploited rather than equals to be respected. Unintended consequences of peaceful contact. Even if aliens meant no harm, their arrival could destabilize human civilization. Religions might collapse or fracture. Political systems could be torn apart by debates over cooperation versus resistance. Economies could collapse if alien technology rendered human industries obsolete. A gift of advanced knowledge could save us or overwhelm us. The dangers of broadcasting. Humanity has already sent signals into space, from radio transmissions to the Arecibo message. Some scientists warn that broadcasting our presence could be dangerous. We might be announcing ourselves to civilizations that view new species the way humans once viewed uncharted lands, opportunities for conquest or exploitation. The zoo hypothesis and the dark forest. Several theories explore why we have not yet encountered aliens. The zoo hypothesis suggests that advanced civilizations know we exist but are deliberately avoiding contact, treating us like animals in a cosmic nature reserve. If this is true, then any attempt we make to reach out might provoke them to intervene, perhaps violently, if we disrupt their plans. The dark forest hypothesis, popularized in science fiction, paints an even bleaker picture. Imagine the universe as a dark forest filled with hunters. Each civilization is armed, but no one knows the intentions of others. To survive, the safest strategy is to remain silent, or to eliminate others before they eliminate you. If this is true, then making ourselves known could be a fatal mistake. Lessons from human history. History provides grim parallels. When technologically advanced civilizations encountered less advanced ones, the results were often catastrophic. The colonization of the Americas, the British Empire's expansion, or countless other examples of conquest. Disease, slavery, and cultural annihilation followed. If aliens arrive, we may be the less advanced species in that equation. Even if aliens came peacefully, the shock of their presence could still mirror cultural collapse seen in human history. Entire belief systems could crumble overnight. Political regimes might fall as populations demand cooperation with, or rebellion against, the visitors. The world could plunge into chaos without a single alien weapon fired. Can we survive alien contact? Humanity's survival in an alien encounter would depend on several factors. Technological gap. If aliens are only slightly ahead of us, we might compete or negotiate. If they are millennia ahead, survival may not be possible at all. Intentions. Hostile aliens would be catastrophic, but even indifferent ones could destroy us simply by neglect, the way humans destroy insect colonies without noticing. Human unity. A divided humanity would be easy to conquer or manipulate. Only unprecedented global cooperation could give us a chance at survival. Preparing for the unknown. Though alien contact remains speculative, some scientists and policymakers argue we should take the possibility seriously. This includes protocols for first contact, international agreements on how to respond to alien signals or arrivals, caution in messaging, debates over whether humanity should send active signals into space or remain silent. Strengthening humanity. Regardless of aliens, building unity, resilience, and advanced technology improves our survival odds in any existential threat. Conclusion. The idea of alien invasion or contact gone wrong may sound like science fiction, but it underscores a deeper truth. Humanity is not alone in facing the unknown. The universe is vast, mysterious, and potentially dangerous. Whether aliens exist or not, contemplating this possibility reminds us of our own fragility and our need to prepare for threats, both known and unknown. If we one day gaze into the stars and find we are not alone, the outcome will depend not only on who they are, but on who we are when that day comes. Will we meet them as a fractured, fragile species, or as a united civilization ready to face the cosmos? Throughout history, humanity has lived with dangers, plagues, wars, famines, and disasters. Yet never before have we had such a clear understanding of the risks that threaten not just nations or generations, but the very survival of our species. From nuclear war and pandemics to climate collapse, runaway technology, and the silent menace of cosmic forces, we stand at a crossroads between survival and extinction. The 10 scenarios explored in this article share a common theme: fragility. Despite our intelligence, culture, and technology, humanity remains vulnerable. A single asteroid, a chain reaction of political collapse, or a runaway artificial intelligence could undo everything our ancestors built over millennia. Even threats we create ourselves, nuclear weapons, ecological damage, or uncontrolled technologies, show how easily human progress can become human downfall. Yet there is also resilience in our story. We have survived ice ages, supervolcanoes, and near extinctions. We have built civilizations that span continents and connected a planet with trade, ideas, and technology. These same qualities, creativity, cooperation, and foresight, give us the tools to confront the dangers ahead. The future will not be secured by denial or complacency, but by preparation. We must strengthen global cooperation, recognizing that existential risks are not confined by borders. Invest in resilience, building systems, food, energy, communication that can withstand shocks. advance science responsibly, ensuring technologies like AI and nanotech are developed with safeguards, expand beyond Earth not as escapism, but as insurance that no single disaster can end the human story. Most of all, we must cultivate a mindset that values the long-term survival of humanity over short-term gain. The challenges are immense, but so is our capacity to rise to them. Every generation inherits both the risks and the responsibility to protect the future. In the grand timeline of the cosmos, humanity is still young. Whether we flourish for millennia to come or vanish like countless species before us depends on the choices we make today. If we face our vulnerabilities with courage, wisdom, and unity, we may not only survive, but thrive, reaching for the stars, carrying the story of Earth into the wider universe. The end of humanity is not inevitable. The possibility of destruction is a reminder of what is at stake: everything we are, everything we love, and everything we might yet become. Our greatest responsibility and our greatest adventure is to ensure that the story of humanity does not end here, but continues richer and stronger into a future worthy of the potential we hold.